and I'm part of the high-performance team in Seattle under the Azure Compute team. And I primarily work on infrastructure, scalable services. For those of you who know Green Button, I was part of that team in Wellington as well. And there's my Twitter handle if you guys want to follow or ask any questions or anything like that. So I'm here to talk today about GPUs. It's the first time we've done this in Azure. And so there's a lot of fuss or momentum around GPUs from a lot of different companies. Amazon made some announcements, a couple of others did as well. And so I kind of wanted to talk about what's the big deal, what's the big fuss about GPUs and why they're so important. And I'll sort of dig into a little bit about what sort of Microsoft as a company has been talking about as well. Earlier this year at Ignite in the US, Satya talked about AI and deep learning. So I'm going to hit some of those points as well. So to start off, I want to talk about 3 different industries that we think GPUs are going to be pretty big or fairly required. Gaming is one of them, but it doesn't extend to gaming. It's more sort of media. It's just the numbers around what the market is like. So these are things like game streaming services. You can think of things like video streaming services like Netflix, Hulu, whatever. And then things such as if you're you don't have to go out and buy a $10,000 rig anymore. You can just launch up a machine in Azure and you're good to go. So we think gaming is going to be fairly important. Xbox and some of the other properties inside Microsoft use GPUs today, and it's for things like dynamic rendering. So if you've got digital assets and you want to render them offline, GPUs are going to be important for that. The other one that we think is huge, or it's going to be huge, is workstations. We think this is going to be a massive market, and this is going from customers that are buying $5,000 to $10,000 workstations, and now they're just moving them into the cloud. One of the big reasons why we're investing from a GPU standpoint in workstations is because most of the customers are producing lots of content. And so if you think about customers doing high-performance computing, they create lots of content. All that data ingress, egress is defeating the purpose of having your clusters in the cloud. And so having a workstation in the cloud where you can just spin it up, create your assets or your digital content, and then do all the work in Azure. The storage, all of your data remains in Azure. Nothing goes on-prem. That's kind of the vision moving forward. And additionally, we worked with NVIDIA to sort of embed some of their workstation technology into our GPUs, which is going to be one of our other differentiators that I can talk about. And then finally, automotive is one of the industries, but what this is really talking about is things like autonomous driving is going to be massive. So AI and deep learning in this space is going to be huge. Every car coming out there is going to have some form of AI where it's doing speech detection for things like if you're telling your car to do something like detect an object, or Tesla coming out with the next autonomous driver's car where it has to go detect pedestrians, for example, or objects. All of this is going to be using GPUs underneath the covers. So in Azure today, we've had GPUs in preview since August timeframe, and so I just kind of wanted to share some social activity or just some excitement around what people sort of think about this offering, but also how people are reacting to this stuff. It's crazy. We've underestimated how much people use this stuff for all sorts of different purposes. You're seeing people use this for 1080p streaming and gaming, and I'll show some demos that will relate to that. People, instead of buying workstations, are buying 10 hours worth of compute so they can run Photoshop to do some project. So there's lots of really, really awesome stuff that we've seen people are doing on these things. Obviously, you can see bottom left there's a game engine running there as well. So there's lots of interesting things people are doing, and we're super excited that it's kind of blowing across as more scenarios have come on board. So to talk a little bit about what the offering is, what is the offering in Azure? Obviously, this is the first time we're doing it in, so we wanted to make sure that we have a really high fidelity. And one of the reasons why the high performance computing team is delivering the GPUs is because we think of it from a performance standpoint. This is not a commodity offering. This is a specialized VM SKU, essentially. So the first half of the offering is the compute virtual machines, and this is powered by NVIDIA's Tesla K80 card. It's a dual GPU design, so it's a physical card with 2 GPUs on it, but they pop up as separate devices. And essentially, you're going to be able to get 1 to 4. So our full node is going to have 2 full physical cards, meaning 4 GPUs, and you'll be able to utilize things like OpenCL, CUDA applications, anything that you run your algorithms on. So this is a great card for like HPC applications or any CUDA-based compute, GPU type stuff, or database processing, or GPU-based database processing, or things like deep learning, AI, machine learning. All of those scenarios are going to be fantastic on that card. Additionally, at the end, you can see we've got a VM size that says NC24R, and the only difference there is that we've got a separate network. So we've got a second backend network, 40 gig backend network that is going to be allowing you to do RDMA over infinite band, which is basically low latency stuff. So what that means is if you're running workloads, very high, very compute intensive workloads that require multiple machines to string together. So if you're doing like deep learning or AI or machine learning, and you have a single job with, say, multiple tasks, and you're wanting to string along multiple GPUs, not even on a single node, but multiple nodes, you're going to be able to get close to bare metal performance on these things across different nodes. So we're talking like under 3 microseconds for latency between a physical node to a physical node. That's going to be pretty crazy performance when you're scaling up. And that's kind of been Azure's strategy all along from a networking standpoint, is we always think that scaling out is going to be the future as opposed to scaling up. We don't want to go build the biggest, baddest box, but we want to make sure that scale out is really good. Additionally, those are 6 cores. Those are 6 physical cores, not hyper-threaded. So that additionally is another plus for HPC applications. And Tesla K80, it is really fast. I can't stress that enough. Obviously, there's going to be more generations of new GPUs coming out in the coming years and the coming months. But from a cloud perspective, as of today, this is really quick when compared to a CPU. In some cases, it's almost 20 to 50x performance upgrade from a single CPU to a single K80. And by single K80, I mean half a card. So even with half a card, you're getting some incredible performance. So I want to dig into AI a little bit. Satya on stage earlier this year, only a couple of months ago, a couple of weeks ago, in fact, talked about AI being kind of the next sort of vision from a perspective of what we're going to be doing inside Azure, inside different various products. AI is going to be embedded in every single product inside Microsoft. Office, obviously now LinkedIn, Skype, all of the Bing products, HoloLens. All of those things do some form of AI or deep learning in the back end, and all of that requires GPU. So AI is everywhere. So some of the examples, kind of every time you talk to your phone to say something, that's all AI neural net driven models that are basically saying, where did I park my car, or give me the latest weather, or give me the latest score for a cricket match or a rugby match or whatever. This is all neural net and AI driven based interaction. Additionally, things like, hey, I saw a product on a magazine, and I want to find out where on Pinterest is this product posted. And Pinterest will actually go do a bunch of object detection to go and see where on their website or their entire mammoth of data is the same product being posted different places. And then things like recommendation engines is all powered by AI as well. So Netflix, all of the different video streaming services, they'll do things like they'll search your entire history of movies and things that you've watched, and then they will recommend what you should watch coming up, or they will take preferences of different people, string that together, and create very intelligent models about what you should be watching or what you are interested in. So these are some really interesting things that AI is driving. And then it's also touching lives. This is really important. So there's a couple examples here that I want to talk about. So like Skype, for example, Skype Translator is now allowing the possibility of language barrier to not be a problem anymore. So a grandmother in Italy can talk to her grandson in the US. And it's all being driven real time by a speech algorithm, essentially, and which is all being trained on a corpus of speech data, using GPUs. Additionally, healthcare is changing with AI as well. So, this is the Los Angeles Children's Hospital, where essentially they're taking a decade of medical data, which means heartbeats, blood pressure, whatever, and they're taking all of that and training a model so that you can tell now in the future what type of medication you can do, preventive measures, and what type of symptoms relate to what type of diseases. This is really going to change how we do things in the healthcare in the future, and all of that is being driven by AI and training models, and then all of it run on GPUs. And then this is our very own blind project in Microsoft, where essentially this person here has glasses which has a camera attached to it, and then the camera talks to his phone, and then basically sends images up to the cloud to say, okay, what am I looking at? And so it changes completely how he interacts with the world. So he can actually see menus now because it's reading the objects, it's reading the text, and it's telling him through a microphone and a speaker what he's actually seeing. He can now tell jokes, and he can actually see from cognitive services if the person is smiling, frowning, agitated. He can actually tell what's going on. So this is really life-changing stuff that's being built on AI and GPUs. And then it's fueling all industries as well. So we're seeing just change everywhere. So this is, for example, things like malls or airports, where if you lose your child, you can literally take a photo of your child, take it to the security office, and then they will search all of the video streams dynamically in real time to find the last known place of your child. And this is happening today. You can sort of imagine the same sort of scenarios in different cases like airports to find people. Additionally, the second one is a pretty cool hotel concierge service, where this is a bot essentially that will talk to you about different things. So you can talk to it like a normal person and say, I'm interested in sushi, or what are the points of interest, or this is my first time to Japan or New Zealand or whatever, and it will actually converse with you and and talk to you and suggest ideas. In fact, this is actually in MSR today as well. We have some of these lying around in the campus, so it's pretty interesting way to think about how it's going to change the future. So you'll be able to interestingly say, hey, can you purchase this for me, and it will go back and then go and purchase on a website for you for goods. And then it's also changing agriculture quite a bit. So this is a project called the Lettuce Bot project, and this is a lettuce field. And what's happening here is in the front of the tractor, it's got essentially cameras to recognize what's in front of it. So it can be either lettuce or a piece of weed. And so if it's a piece of weed, it will just spray enough herbicide to kill the weed. And this is basically giving them 95% reduced or 95% better usage of herbicide, essentially. And then it's also got great healthcare benefits as well. So they're actually changing how they're actually doing this stuff in agriculture as well. It's pretty incredible. So I think the rate of improvement is really what drives the use of GPUs in this case. So as soon as sort of GPUs came on board, you could see that the accuracy of these models has gone through the roof from a point of view of AI and deep learning. And very quickly as well. That's kind of the important part. And it's going to keep getting better. So you can see, ImageNet is for image recognition, pedestrian detection, object detection. These are all models or different types of models that have been created. And you can see from a CPU versus GPU standpoint, it's going to be fairly more faster, but also very accurate. So a lot of people ask, what the heck is deep learning? How do you use it? How does it work? What's the difference between it and machine learning, things like that? And so I just want to take a few minutes to talk about, what essentially is deep learning. So deep learning has two parts of it. There's the training side and there's the inference side. So essentially, training side is really taking, a computer and teaching it how to recognize certain things, or how to think about what it is. So you can feed it. Basically, it's an empty brain, and you feed it a corpus of data. So you can feed it images, you can feed it wave files, audio files, video files, whatever, and you would feed it lots of data so it can learn about those things. So this is a cat, this is a dog, this is a pen. or this is how you describe a car, or this is how you describe a certain color. And you feed all of that data, and most of the data scientists will do this training over and over and over again. You'd be doing this a lot of times. So essentially, you're running billions of teraflops of training per run. And you always do it in the complete data set. You're never doing chunking, essentially. You're never taking a piece of that data. You're always taking the entire data set. So you can think about like social analytics. So what are people talking about MS Ignite New Zealand? So you can take that entire data and get sentiment out of it. And they'll do it until you hit a really high level of accuracy. So somewhere about 85 to 95%. And once you do that, then you get into the deployment side of it, which is the inferencing. So this is like basically my phone, and then I'm talking to it. You can do a couple of things. You could take all of that data, and then you can put it in cold storage and then actually get some learning out of it. Or you could do it as a service where you're essentially doing, building even more learnings out of it, like, this is a cat. And then you essentially feed your inputs into it. So you can feed a frame of, a cat, and it will actually recognize what it is. So this is a sort of a virtuous cycle that is very compute intensive, requires lots of compute power, GPUs, to do it. And every deep learning framework is GPU accelerated. So all of this work, this training, this inference is all done by a software that is, or toolkits or libraries that are actually built for doing the training. Lots of them are academic based, but we also have our own. CNTK is Microsoft's own deep learning toolkit. Super simple to get started. And essentially it's fantastic for doing things like speech training. You essentially feed a lot of data to it, it trains the model, and then you can then infer on it. This is super recent. This is like a couple of days ago, and I thought I'd include it here to sort of talk about some of the advances in AI and deep learning. Basically, this is run through CNTK, which is Microsoft's own deep learning toolkit, and now the actual recognition is now on par with humans, essentially. That's crazy, right? So it's now within 5.9% of what actually real transcribers sit on there and actually look at all the data coming through, which is pretty incredible. So, and it's only going to get better. So this is kind of the level of where we are today, and all of this training is done, all of it on GPUs. To talk a little bit about a few examples, video is a pretty hot topic right now these days, and people want to extract information out of video. And so this is 90 concurrent streams running on a single GPU, essentially recognizing what's happening. So if I actually zoom into one of these things, looks like I can't zoom, but essentially what you're seeing here is on the top left side, you can see essentially what's happening in the video. And this is a single GPU recognizing every single frame on every single stream of that video to tell you what's actually happening in the video. So you can then make intelligent decisions about, should I share this video publicly? Should I not share this video publicly? Should I share it with my colleague? Should I share it with my friends? Is it safe to share these videos? Is it not safe? It's actually telling you what's actually happening inside that video on a single GPU, and that's kind of the power that we're seeing with these things. Another sort of fun example is you guys might have seen this in different applications and things, but you can download a bunch of apps on your phones. But essentially what this is it's taking a vanilla model, and then what it's doing is it's feeding through every Picasso image or every Picasso painting into that model for that model to learn about what Picasso is doing or how he paints. And then it's feeding through, on the inference side, it's feeding through real-world video images and frames to basically showcase what Picasso would have done with the current video. So this is kind of a really fun example to showcase different sort of filters and things like that. But essentially, we're feeding through the entire video, and each frame is being inferred using the training that we've done using the Picasso frames. So this is pretty cool. It's going through a bunch of filters, but kind of the cool things that you can see what this technology is capable of, and you can also sort of think about how this will affect what you do in your company as well. So pretty cool stuff, and all of this is dynamic running on a single GPU, dynamically inferred. Here's another example. This is basically a terabyte of data being fed through a GPU to recognize and talk about how tornadoes are built and how tornadoes and what makes them dangerous, essentially. So it's taking all of the data and it's actually thinking about, okay, what is it that makes a tornado dangerous, so that they can then use that learning to say, okay, should we go and actually send out a preemptive emergency recording or an emergency message. So it's actually going and thinking about what makes these things dangerous, what is the data, what makes the characteristics of these things, and it's basically taking all of that data and then extracting learning out of those things. So I'm going to show off a quick demo of what this actually looks like live and what you can actually do with it. So let me go ahead and do that. All right, so what we got here, we've got here is essentially I've logged into a Linux VM, and what we're going to be running here is a bunch of different things. We're going to be running essentially a training job. So this is basically taking 60,000 images and training a vanilla model, a convolutional model, to essentially recognize handwritten digits. And so on the left side here, what you can see is basically a CPU VM. It's remoting into a CPU VM. And on the right side, we've got a single K80 GPU VM running in San Antonio data center. That's our first public preview cluster. So essentially what I'm going to be doing is running a CPU training model. And this is going to run different batch sizes. So essentially, in a training model, you have different little mini batches of trainings that you'll be doing. And this is running on I think a D machine, a D series machine. So about two cores. And then on the bottom, you can obviously see some utilization of the cores as well. And it's going to be starting the mini batch loop. There's about 15 batches of it. And it's running through essentially Azure Batch, which is a scheduling service in Azure. It's using Azure Batch to then schedule CNTK, which is our toolkit. And it's running it via Docker on a Linux VM. And then on the right-hand side, I'm going to be running it on a GPU. The same allocation, but essentially I'm going to be doing it on a GPU. Now, this may be hard to see. Let me just try and zoom in again if I can. There we go. So the thing to notice here is essentially the samples per second. This is how many samples, or this is how much data the actual physical hardware can talk through and train. And here you can see there's about 823 samples per second on a single CPU. And then on the right-hand side, if I actually zoom in again, on the right-hand side, you can see it's about 10x better. So about 12,000 or more than 10x essentially. So it's really churning through. On a single GPU, it's churning through that training data like crazy. So right now, we're already on the 7 of 15 mini batch, whereas that one is, I think, still the first one essentially. Additionally, on the right-hand side here, what you can see is a tool called NVSMI. This is actually shipped with the Azure GPUs today. It's a tool that will essentially give you a bunch of data, metadata about the GPU, the physical hardware itself. So you can see that it's got a single Tesla K80. And that single Tesla K80 is essentially half the card that I talked about. So it's the NC6 VM. And then what it's actually showcasing is the utilization of that GPU on the 78%. And then it's actually even showing you things such as the temperature, the thermal temperature of the GPU in the data center itself. So this tool ships with the GPU VMs, so you can look up all sorts of metadata about it. Now, you can see that on the right-hand side, the training's actually already completed. On the left-hand side, it's still going. Now, this is just a very simple example, but it's kind of showcasing the power between what you can and can't do. And this is training, again, 60,000 images to recognize digits, right? So you can extrapolate this out to whatever, like objects or pencils, whatever, images of stuff. Now, so I'll exit out of that, so I'll keep that running. What I will do now is actually, this is the training side. So what do I do with this model now, right? So let me go ahead and bring up our very fancy application called Paint. And it's got a square in here. And so what I'm going to do is I've got a pre-trained model. And what I'm going to write is I'm going to write a little digit, basically. So anybody got ideas on what I should type? Any number? 0 to 9, single digit. 7? Let's do that. Ooh, that's terrible. So I'm going to save that. And then essentially, I'm going to run my inference model on that image. Okay, so it talks it as 4. Let's go back and type in 7 again. Maybe I'll do that this time. 1. If I do that. 4, okay. Let's try it again. 4, okay. Maybe it's my handwriting. Another number. Let's do maybe 5. 5, yay, okay. So this is not smoke and mirrors, right? So I'm not actually faking this. This is actually happening. So obviously we got the 7 wrong. So it's actually being fed through 60,000 of images, and it's training as to how people write certain digits. And then I'm running the inference model, or I'm running the inference against that trained model to recognize what my handwriting is for that digit. So you can, again, as I said, you can extrapolate this out to being, whatever, basically, to do whatever kind of scenario. So let's see, 8. 8 generally doesn't work for me. It's surprising that, there we go, so that said 8. So interesting 7 didn't work, but that's maybe the way I write it, right? So that's an interesting way to showcase. And again, this model and this code is actually open source on GitHub. I'll have a link at the end. Essentially, it's using Azure Batch to deploy an image of CNTK on Docker, and then it's scheduling the VMs on GPUs. So you can use that today. All of the code, including the sample, is available on GitHub. So I'll share the data. Cool. So the second part of this offering really is talking about visualization. Once you have all that data, you're gonna have to have some way of utilizing that data, visualizing it in the cloud. And that's the second part of our offering, which is M60, based on Tesla M60 GPUs. Again, dual GPU design from NVIDIA, and the same VM sizes, but essentially swapped over with an M60 GPU. One of the interesting things we're doing in this case is these GPUs are powered by NVIDIA Grid, which is essentially NVIDIA's version of their visualization offering. So essentially it allows you to run different types of hardware accelerated applications that maybe use DirectX, OpenGL, CUDA, whatever, on these applications. So your engineer can essentially, or your engineer, your designer, whoever can essentially spin up a VM for 8 hours a day, run their work, create the assets, create the content, the models, and then essentially shut it down on demand. So you could have various images. And actually, let me go back a second. One of the cool things we're doing in this case is how we're exposing these GPUs. Server 2016 just GA'd a couple of weeks ago. And in Azure today, in all of Azure today, our host OS is Server 2012 R2. And then you have the hypervisor, which is the Hyper-V, and then we have whatever guest, Linux, Windows, whatever you want. In the case of GPUs, what we're doing is we're actually having a Windows Server 2016 as our host OS. And as part of the hypervisor of the 2016, one of the features that we've introduced is called DDA. It's called Discrete Device Assignment. And what it allows us to do is it allows us to physically pass through hardware directly to the guest without any performance degradation. This is really, really breakthrough from a cloud perspective because it gives you almost native performance on a VM for a hardware. So there's no virtualization of the GPU happening, essentially. We just unmount the device from the host OS and we just assign it to the guest.
Does that slide, I mean, do that
No.
I couldn't do it 2012, so I had to use Zen to
No, so that's a layer above, right? So you're running Zen on top of the guest, right?
No, I'm running Zen server.
On-prem, you mean?
Yeah.
Ah, okay, yeah, so it's available only part of 2016. So this is a feature only for 2016 as of today.
Right, so it's available for me today.
Yes, you can download Server 2016 and the same architecture that we run on Azure, you can run on-prem. Absolutely. So basically what it does is it takes a PCIe device, and these GPUs pop up as PCIe devices, and you can just directly pass them through using Hyper-V.
So a guest OS on that, then, if it needs to move to a different host, can you cluster those cards anyway so it handles the hardware transfer, or
Yes, so Hyper-V does that for you. So
with GPU?
with GPU, well, any PCIe device. GPU in this case, yes, but any PCIe device. It could be whatever, right? But in this case, we're using DDA for GPUs because it's a PCIe device. And you can attach multiple GPUs into a single VM if you like. And that's through Hypervisor, Hyper-V as part of Server 2016. Only in 16, so the host OS has to be 16, and Hyper-V is the hypervisor in this case.
Right.
Yeah.
If I had 3-node cluster, each physical device running those cards, and I had a VM on one of those hosts with standard wire, I could pull the plug on that, transfer to the next one, and pick up the GPU.
Yes. Yep. So what it also allows us to do is install native drivers on the guest OS as well.
Oh, cool.
Yes. So in this case, when you launch a VM, you actually won't see a GPU. We'll provide a driver, which you will then install on the guest OS, and then the GPU will pop up. It will recognize and it will talk to the host through the hypervisor. Yeah. So this is a really cool thing. So DDA is going to be sort of game changing from a performance standpoint. Obviously, it exposes the hardware directly to the guest. And we've done some benchmarks, and we're seeing, for some workloads, we're seeing up to 95% performance compared to bare metal, which is pretty fantastic, on the GPU, obviously. And then additionally, as part of this work, we've worked pretty hard with the remote desktop services team to integrate and utilize any of the DDA work that has been coming through as well. So RDP guys have done a lot of work to improve the performance and improve kind of the H.264 remoting protocol that they're using today. It is only available, so these changes are only available via 2016 running DDA and then Windows 10 as a guest. And so these preview clients are available now. And it will give you much better capability to run things OpenCL, OpenGL, all of those. Additionally, as part of our release, what we've done is we've partnered with Teradici, which is another remoting protocol provider. Their protocol is PC over IP, and they are a piece of software that essentially will allow you to do very high-end workstation type scenarios. So if you have a designer or an engineer and they're using a very high-end application and you require things like multi-monitor, 4K streaming, peripherals like Wacom tablets and things like that, Teradici will allow you to do that. And again, the client is available either on a soft client, so like your laptop, and you can, it could be a Mac, iOS device. I can even use my iPhone for it. Or you can use essentially what's called a Zero client. It's a little device that plugs into a network cable, a bunch of monitors, and essentially if you wanted to attach peripherals to it, and you can then just connect into Azure using that as well. So again, this is actually available today, and they're going to be supporting a subscription-based model as opposed to perpetual models, which is pretty cool because then you can launch a VM, use it for however long you want, and only pay for what you use, which is pretty fantastic. So this is going to be, I think, really, really great from an enterprise standpoint. So I'm going to show some other demos as well. So let's see what I've got here. So this is obviously for a, and this will actually show you, with the device manager as well, what we can do. So let me get out of there again. So what I've got here is an application called Rhino. It's just a 3D modeling application, and what I've installed here is called NVIDIA iRay, which is a GPU-based renderer provided by NVIDIA. And I'm remoting in to a San Antonio data center VM using RDP. And this is obviously running a model. So previously, what was not possible was a way to visualize these things in the cloud. So I can look at the wireframe, I can look at the model, I can look at the scene file, but I can't actually do anything dynamic to see how does this relate to my final end product. What I can do now is actually dynamically select, this is going to be very small, but it will give you the idea, is what I can select now is iRay. And this will dynamically generate the materials, the lighting, the ray tracing, everything in the cloud because it's got a GPU attached to it. And you'll be able to quickly kind of do previews like this to really recognize what's actually going on. Metal looks like metal, plastic looks like plastic, shadows look the way that they're supposed to look. And I can then iterate on my model and my visualization very quickly. I don't have to actually go off and render a high-def image, or I don't have to go off and do anything separately. I can just do this in the GPU VM, and the data just remains in the cloud, all of that there. So this is a pretty cool example to showcase that. Yep. Yeah. The second example is through Teradici, in fact. So what I've logged into here is, again, another VM. It's based in San Antonio, so I want to stress that fact because it's really far away. And I'm on, whatever the demo Ethernet thing, right? So the networking here. So I'm hoping, I pray to the gods that the demo works well, but essentially what this is showcasing is, number one, we have a GPU VM attached. So that's why I kind of mentioned, right? So this is a physical device that's attached as a display adapter. When you launch the VM, it's going to just look at a Hyper-V display adapter, and then you install the driver, and then it will recognize itself as a GPU. So you can see that we've got here a Tesla. We've got here a Tesla. If I can zoom in. No, it won't let me zoom in. OK. Essentially, what I've got here is a Tesla M60. This is grid-enabled. And one of the other things that we've done is we've partnered with NVIDIA to associate or compound the cost of the licensing in the VM cost itself. So today, if you want to use Grid, you have to go to NVIDIA, you have to purchase a license, you have to then run a Flexera license server, and then connect it to your VM so that it can authenticate using the key, and then you can finally run it. In this case, there's none of that. You just launch the VM, you install the driver, and you're good to go. The Grid licensing cost is incorporated into the VM cost per hour, amortized over the minute. So what I'm going to run here is called 3D Mark. I'm going to kick this off. I'm really hoping that the network stands up here. But essentially, what I'm doing here is this is a 2012 R2 VM. That's just a guest. Obviously, the host is still 2016. You can run 2016 here as well if you want to, or in Linux distros as well. So 3D Mark, some of you may know what this is, but essentially this is just a benchmark. And what I'm doing is I'm going to run a dynamic, so this is actually going to happen in real time. It's a dynamic game engine being rendered to showcase the power of a single GPU. And this is being, again, streamed through Teradici PC over IP client all the way from San Antonio. And it's a 1080p stream. Now, on a single M60, you can run 36 concurrent 1080p streams, which is kind of showing you the power of what these things are possible. Hopefully, once this loads, you'll be able to see sort of the cool things you're able to do with these GPUs. And if the network holds up. So this is a 1080p stream. I can actually, I can turn it down to 720 or whatever, but this is kind of showcasing you. This is happening in real time. This is not a video. This is a dynamic scene getting generated in the VM, being streamed directly from US, Texas data center. And you can sort of see the fidelity here and see, that's me flying down with my friend Eagle. So this is pretty cool. So this means you can build actual SaaS services on top of these VMs. Think Netflix, think gaming streaming services, think even workstation as a service, right? So you can provide essentially a endpoint, and people can do whatever they want on these powerful machines. Again, this utilizes Grid underneath the covers from NVIDIA, which is pretty cool. And this is all getting dynamically generated in the VM being streamed through. Any questions on this while this is running?
What do you think client?
Sorry?
Why are you using that client?
So it's doing a bunch of, so it's a completely different encoder. And Teradici's got some secret sauce in there to make it much more smooth and also very high fidelity. So RDP uses H.264. Teradici uses PC over IP, so it's a slightly different methodology. Additionally, this also utilizes grid natively, which RDP doesn't. So if you're running any apps or anything that utilizes grid, there's Teradici. That we've also partnered with Citrix. Actually, I failed to mention those guys. So Citrix has also announced a couple of weeks ago support for the M60 via their enterprise agreement, so you can actually run Windows 10 as a client if you need to. But again, we've done most of our testing and things on Server 2016, 2012. Whenever the licensing for the general public changes for Windows 10, we'll support that too. So this is just a pure IaaS, infrastructure as a service VM available through Azure. The current data center today, the only data center today that we have GPUs in today is the San Antonio, so that's the South Central region. Over the next couple of months, or actually the next couple of weeks, we're going to be expanding fairly aggressively to Europe, to APAC, Asia, and then a bunch more data centers as well. So, in the next 6 months, we're going to have almost 30. We're going to 10-20x our capacity essentially. So this is going to be, again, just a normalized VM. You can go to the portal, you can launch it. The documentation will give you the location to the drivers. You can just install the driver and you're good to go on a per minute billing basis. So it's pretty cool. So I will switch back to my boring. The video is much cooler, but gotta finish off. So. Don't forget, there are two different offerings, the M60 and the K80. NC stands for compute, NV stands for visualization, simple enough. NC will support CUDA, OpenCL-based compute, single precision and double precision floating point compute. NV will support M60, DirectX, OpenGL, out of the box. And then additionally, I've got a bunch of links here. If you would like to sign up, our preview is very full. But if you would like to sign up, and as more data centers and capacity comes online, we will open it up. So please go ahead and sign up at gpu.azure.com. And if you wanted to actually go and try the demo that I showed with the Linux VM and the hand recognition stuff, you can actually run this stuff on CPU as well. So CNTK scales very well across CPU. And obviously, the big feature here is GPU, but you can actually download that sample today. It uses CNTK, but you can also use Google's TensorFlow. You can use Caffe. You can use Theanos. All the different libraries and things available, and all of those samples are online on aka.as. Try Azure HPC. It uses Docker. It uses Azure Batch. Runs on Linux. Available open source. And then if you wanted to get a trial of the Teradici VM, you can actually run this on CPU and GPU. Obviously, it'll be accelerated and using NVIDIA Grid if you would like to use GPU. They've got a 60-day trial for any N-series users today. So you can visit their website, sign up, get a link, get a key, and you will be good to go. And then if you'd like to find out more about NVIDIA Grid, it is pretty cool. And then IRA, which is the renderer that I was running as well. And that's it. So that's my Twitter handle. Ping me if you have any questions, or I'll take some questions now. I've got 15 minutes.
Sharing of the graphics card. So if you were running a cluster which has got multiple VDIs, and the requirement is that you need to present the GPU to say at least more than one VDI. How does that sharing of the
Right. So you're talking about vGPU and GPU sharing, right? So we don't do that today. There's reasons for it, and there's reasons not for it. What I mean by that is it makes more sense to do GPU sharing for an M60 card, primarily because of cost, benefit, right? Not because of performance. So you're essentially taking a single GPU, you're putting what's called vGPU layer, and then essentially splitting up the GPU in pieces and giving it to each VM, right? So we don't do that today. There's nothing stopping you from running whatever on top of a VM and running some kind of interface layer on top of it. But today, as of today, we don't support GPU sharing. So you get a dedicated physical GPU assigned to your VM. I mean, again, I'm happy to hear feedback on if it's actually a blocker or requirement. What we've seen from customers is because these things are a niche today and they would like to run it for best in performance, they do like to see the dedicated GPU assigned. But if there's a requirement for vGPU, I'd love to hear it and connect offline. Yeah.
Just on that, I've been doing it in the terms that we'll have an app session server. So you make an app session and that runs.
Yep.
Can I do that? So we're not sharing across multiple VMs. There is one VM that's creating multiple sessions.
So you're basically talking about concurrent users, right? So you spin up a single GPU and then you have multiple users log into that basically at the same time. Yes, but it completely depends on the application and how that scales. So some applications won't actually allow you to do it. Things like very high-end automotive-based applications will limit you to a single user and captures a session. Whereas some other apps, you can absolutely do it. But then again, it depends completely on the application and its ability to scale and use the GPU under the covers. And again, it depends on the client, right? So I think Teradici allows, a lot of concurrent, but RDP allows like something crazy, like 36.
Your terminal server licensing should be able to help you in that case.
Yeah. One other thing to also note is that the GPUs currently, as they're licensed for the M60 specifically, for Grid, it's a single GPU, single user. Now, again, it's an infrastructure VM, so you can put whatever on top you want and then use that. But at the infrastructure layer, what you're paying for in the GPU is a single license for a GPU for the Grid. Yeah.
Do you know when the Australian Azure data center is going to be in a few years?
We're working on that. So we are going to be, so as I said, our current preview cluster is in San Antonio. We are going to be expanding to sort of the bigger hubs initially, as aggressively as possible in the next, I would say, before the end of the year. So some of the bigger ones like Europe, Singapore, things like that. So Singapore is going to be actually in the next couple of weeks and months. We'll make an announcement over that, and then we're working on Australia, UK, and a couple of others as well, but nothing concrete yet. Yeah.
Can you access that San Antonio region through your existing Azure subscription?
Absolutely. Absolutely. Yes. It's just another region. Yeah. Everything in Azure today is region-based. So when you click New, you just select whatever region you want, and if you want to pick US, nothing's stopping you to do that. Yeah. 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 Cool. Any other questions?
Would that mean you'd have to move data set to US as well?
That's correct. You would have to. Well, it's preferable due to the latency. You don't have to, but if you want optimal performance, you want to make sure the data locality to the VM. It depends. So on the M60 side, absolutely. I think if you want a workstation-like experience or something that's you feel like something's under your desk, then yes, you absolutely want the data to be located right next to your VM. Now, if it's compute based on the K80, doesn't really matter. The data transfer, yes, when you're talking gigabytes or terabytes of data, but then the actual training can take forever. So offline rendering or training, compute-intensive tasks can take forever, so it doesn't really matter on the compute side unless you get into tens and hundreds of terabytes of data. But absolutely on the visualization side, I think it's very important. Yeah. Yeah. All right. All right. Thanks, guys.